Okay. So, theorem number 5, the opposite angles of a cyclic quadrilateral the opposite angles of a cyclic quad are supplementary, meaning they add up to what? 180 degrees. I thought I wrote quadrilateral, but I wrote quad. Okay? So now, firstly, what is a cyclic quad? So a cyclic quad is a figure whose all vertices lie on the circumference of the circle. So once you see a four-sided figure inside the circle, and you can see that all the vertices of this figure lie on the circumference of the circle, then you got all the right to conclude that that figure is a what? A cyclic quadrilateral. Okay? So now the first property of cyclic quadrilateral tells us that the opposite angles of a cyclic quadrilateral are what? Are supplementary. Meaning that when added together, they shall add up to what? 180 degrees. So we are to prove that theorem. So here we are given circle with center O. We are given chord AB, chord AD, chord DC, chord BC, and they make a four-sided figure. And all the vertices of this figure are where? On the circumference of the circle. So I am to prove this property of cyclic quadrilaterals, which state that the opposite angles of a cyclic quad add up to what? 180 degrees. So if we look at angle A inside this figure is opposite what? Angle C. Angle B is opposite what? Angle D. So as per the theorem, it is expected that angle A and angle C shall make what when added together? 180 degrees. As well as angle B and angle D shall add up to what? 180 degrees. Okay? So as you know that so here we are to prove that this angle A and plus angle C, they add up to what? 180 degrees. So as you know that to prove each and every theorem, we shall make what? A construction. So we construct first. So this is the construction that we are going to do. We are going to join radius BO as well as radius OD. So our construction was to join OB and OD. Okay? So now the theorem that is going to help us prove theorem number 5 is theorem number 2. As you can see that by joining these two radii at the center of the circle, I now have two angles. You can see that, right? As I'm saying that the theorem that is going to help us is theorem number 2. So what does theorem number 2 state? Theorem number 2 states that an angle at center is equal to 2 times an angle at the circumference, but provided that they are subtended by the same arc or chord. So we look at this angle O2. This angle O2 here in the center is subtended by what? By arc BD. So this arc BD, the lower part of arc BD, subtends angle O2. So this lower part of arc BD subtends angle O2, and at the same time, this lower part of arc BD subtends what? Angle A. So angle O2 there is going to be 2 times angle A. Why? Angle at center is equal to 2 times angle at circumference. Okay? This is the first thing that we can write about with theorem number 2. But once again, if we now look at the upper part of arc BD, this upper part of arc BD, you can see the upper part. So now, since the lower part of arc BD subtended O2 and A, so now the upper part of BD is going to subtend which angle at the same? O1, eh? So the upper part of arc BD subtends angle O1, and the upper part of arc BD also subtends what? Angle C. So angle O1 is going to be what? 2 times angle C. Angle O1 is equal to 2 times angle C. Once again, what is the reason? Angle at center is equal to 2 times angle at circumference. Okay? But angle O1 and angle O2, they are what? Angles around a point. What do you know about angles around a point? They do what? They end up 360. So now, our angle O1 plus our angle O2, when added together, they are expected to give us what? 360 degrees. On what grounds? Angles around a point. Okay? But angle O1 above, we wrote that angle O1 is equal to 2 times angle C, eh? And angle O2 in terms of A is equal to 2 times A, eh? But I remember our proof, we're going to A and C, right? So we better substitute O1 and O2 in terms of A and C. So angle O1 is 2 times angle C plus angle O2 is 2 times angle A equals to 360 degrees from above. We have a common factor of 2 here, right? So when taking out 2, we're left with angle C plus angle A equals to 360 degrees. So upon dividing by 2 on both sides, A plus C. Divide by 2, divide by 2. So now our angle A plus angle C. What is 360 degrees divided by 2? 180. So now we've proven.